What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find deltas algebraically. Why delta and finding delta is important? It is important for limits topic of calculus. And we know when absolute value of x minus x naught is less than delta, and then the absolute value of f of x minus L is less than epsilon, we can result in limit of f of x when x is approaching x naught is equal to L. It means that the distance between x and x naught is gonna be very small, smaller than delta. Then we can conclude that the distance between f of x and L is very small as well, which in this case is gonna be smaller than epsilon. Now in these examples, we have f of x, L is given, x naught is given, and also epsilon is given. We can find out the value of delta. Let's start from the first one. It says f of x when x plus 1 is the function and L is 5, x naught is 4, and epsilon is 0.01. We need to find out delta. So I'm gonna say f of x minus L is gonna be the absolute function of x plus 1 minus L, which is 5. That's gonna make it as x absolute function of x minus 4. That has to be smaller than epsilon, which in this case is 0.01, which means that x minus 4 has to be less than 0.01 and has to be greater than negative 0.01. And when we want to isolate x, we need to add 4 to each of them. So it's going to be 4.01, and here we have 3.99. On the other hand, we know x, the absolute value of x minus x naught must be less than delta. So x naught in this case is 4. So I'm going to say x minus 4 supposed to be less than delta. So x minus 4 has to be between negative delta and positive delta. So x is between 4 plus delta and 4 minus delta. So based on what you see here and comparing these two, we're going to say that the delta is 0.01. So if x, the distance between x and 4 is less than 0.01, we can say that the distance between f of x and 5 is less than 0.01. So we can say that limit of f of x when x is approaching 4 is equal to 5. So one more time, the distance between x and 4 is less than 0.01, and it concludes that the distance between f of x and 5 is less than 0.01. So that's the precise calculation of a limit. Now let's see another example. Next example, it says f of x is 2x minus 2. L is negative 6. X naught is negative 2. Epsilon is 0.02. Again, we need to find out delta. So the first thing I'm gonna say f of x minus L, the absolute value is supposed to be 2x minus 2 minus L, which is negative 6 in this case. When you simplify it, it's gonna be 2x plus 4. That has to be less than epsilon, which in this case is 0.02. Which means that 2x plus 4 is less than 0.02 and greater than negative 0.02. And then we try to isolate it. 2x 0.02 minus 4, negative 0.02 minus 4, which will be 3.98, negative 4.02. When you divide it by 2, that's going to be negative 1.99, and here is going to be negative 2.01. On the other hand, we know x minus x naught has to be less than delta. X naught in this case is negative 2, so it's going to be absolute value of x minus negative 2 has to be less than delta. So x plus 2 supposed to be less than delta. So x plus 2 less than delta, greater than negative delta. So it's going to be x between delta minus 2 and negative 2 minus delta. So now if you compare it with the values in here, I'm going to say delta minus 2 is negative 1.99 and negative 2 minus delta is negative 2.01, which in this case delta is 2 minus 1.99, which is 0.01, and in here is going to be 0.01 as well. Since they are equal, it's going to be delta is going to be 0.01. So we can say that x minus negative 2, which is going to be x plus 2, supposed to be less than 0.01. Then you conclude that f of x plus 6 is going to be less than 0.02. And you can conclude that limit of f of x when x is approaching negative 2 is going to be equal to negative 6. Next example, f of x is square root of x plus 1, L is 1, x naught is 0, and epsilon is 0.1. So what we need to do, we need to find out delta. Absolute value of f of x minus L has to be less than epsilon. F of x is square root of x plus 1 minus 1 has to be less than 0.1, which means that square root of x plus 1 minus 1 is less than 0.1 and greater than negative 0.1, and then we add 1 to each of them to isolate it. So it's going to be square root of x plus 1 equals to 1.1 and greater than 0.9. Now next step would be to squaring each side. It's going to be to the power of 2, 1.1 to the power of 2, and 0.9 to the power of 2. That will be x plus 1, because square root of x plus 1 to the power of 2 is going to be just x plus 1. Here we have 1.21 and here we have 0.81. One more step, we just need to reduce it by 1. It's going to be 0.21 and here we have negative 0.19. Well, next step would be x minus x naught is less than delta, which means that x minus 0 is less than delta, which means that x is less than delta and greater than negative delta. So we have two values for delta. One of them is 0.21, one of them is negative delta equals to 0.19, which means that delta is 0.19. Since they are not the same, we need to find out the smaller number. So the smaller number is delta equals to 0.19. So we're gonna say the absolute value of x minus 0 is supposed to be less than 0.19, results in f of x minus L, which is 1 in this case, has to be less than 0.1. And the distance between x and 0 is smaller than 0.19, and the distance between f of x and 1 is less than 0.1. So we can say that limit of f of x when x is approaching 0 is going to be equal to 1. Next example, f of x equals to square root of x, then L is 1 over 2, x naught is 1 over 4, and epsilon is 0.1. So the first thing, absolute value of f of x minus L has to be less than epsilon. Square root of x minus 1 over 2 has to be less than 0.1, which is going to be square root of x minus 1 over 2 has to be less than 0.1 and greater than negative 0.1. That's going to be 1 over 2 plus 0.1, 1 over 2 minus 0.1, which will be 0.4, 0.6, and then you square both sides, 0.36 and 0.16. On the other hand, we have absolute value of x minus x bar less than delta is going to be x minus 1 over 4 less than delta. So x minus 1 over 4 is between negative delta and positive delta. So x will be 1 over 4 plus delta, 1 over 4 minus delta. So 1 over 4 plus delta is going to be 0.36. 1 over 4 minus delta is going to be 0.16. And then we need to evaluate delta in each case. 0.36 minus 1 over 4 is going to be 0.11. And here is going to be 1 over 4 minus 0.16, which is going to be 0.09. Which the smaller one, the smaller value is delta equals to 0.09, and we can conclude that absolute value of x minus 1 over 4 is less than 0.09. That we can conclude that absolute value of f of x minus 1 over 2 is less than 0.1. So we can say limit of f of x when x approaching 1 over 4 is going to be equal to 1 over 2. Next example, we have square root of f of x, square root of 19 minus x. L is 3, x naught is 10, epsilon is 1. So f of x minus L has to be less than epsilon. So square root of 19 minus x minus 3 has to be less than 1. So square root of 19 minus x minus 3 between negative 1 and 1. Then you add 3 to each side. That's going to be 3 plus 1, which is 4. 3 minus 1 is 2. Then we make them squared. We have 19 minus x, 16, 4, and we reduce all of them by 19. Now, as you see here, all of them are negative. Now, how do you do that? We basically, what we need to do, we need to multiply everything by negative 1. So the direction of this inequality is going to change. So it's going to be x between 3 and 15. On the other hand, we have x minus x naught less than delta, which in this case is going to be x minus 10 less than delta, which is going to be x minus 10, negative delta and positive delta. So x is 10 plus delta and 10 minus delta. 10 plus delta is 15. 10 minus delta is 3. So delta is 5 in here and delta is 7 in here. So the smaller value is delta equals to 5. So we can say limit of f of x when x is approaching 10 is going to be equal to 3. Why? Because if x minus 10 is smaller than 5, then we can conclude that the absolute value of f of x minus 3 is less than 1. Next example, we have f of x square root of x minus 7, L is 4, x naught is 23, epsilon is 1. So again, f of x minus L has to be less than epsilon. F of x is square root of x minus 4, x minus 7 minus 4 has to be less than 1, which is going to be x minus 7 minus 4 has to be between 1 and negative 1. Then we add 4 to each side. That's going to be 5, and here is going to be 3. You need to square them. (25 plus 7), and here you have 9 plus 7, which makes it 16 in this side and 32 in this side. On the other hand, absolute value of the distance between x and x naught is supposed to be less than delta. X minus 23 less than delta, which means that x minus 23 is between negative delta and positive delta. So x is between 23 plus delta, 23 minus delta. So we have 23 plus delta equals to 32, as you see here. 23 minus delta equals to 60. So delta in this case is going to be 32 minus 23, that's 9. Delta in here is 23 minus 16, that's going to be 7. So the smaller value is delta equals to 7. So we can say if x minus 23 is the absolute value is less than 7, we can conclude that the distance between f of x and 4 is less than 1. So the limit of f of x when x is approaching 23 is going to be equal to 4. Next one is f of x is 1 over x, L is 1 over 4, x naught is 4, and epsilon is 0.05. We can say absolute value of f of x minus L is less than epsilon, supposed to be less than epsilon. F of x is 1 over x minus L, 1 over 4, has to be less than 0.05. Then we can say 1 over x minus 1 over 4 has to be less than 0.05 and has to be greater than negative 0.05. Then 1 over x is gonna be 1 over 4 plus 0.05, and here we have 1 over 4 minus 0.05. So we have 1 over x, 0.25 plus 0.05 is gonna be 0.3. And here it's going to be 0.2. Now what we need to do, basically, we need to inverse them. So that's going to be x. When you inverse them, the direction of this inequality is going to change. So it's going to be 10 over 3, and here you have 10 over 2. So we can say that x is less than 5 and greater than 10 over 3. On the other hand, we have x, the absolute value of x minus x naught is supposed to be less than delta. X naught is 4. So we have x minus 4 is less than delta and negative delta. So x is going to be 4 plus delta, 4 minus delta. So 4 plus delta is 5, which means that delta is 1. 4 minus delta is 10 over 3, which means that delta is 4 minus 10 over 3, which is 2 over 3. And the smaller number is going to be 2 over 3. So the smaller number is delta equals to 2 over 3. So we can say the absolute value of x minus x naught, which is 4, supposed to be less than 2 over 3. Then we can conclude that the absolute value of f of x minus L, which is 1 over 4, has to be less than 0.05. Then we can say limit of f of x when x is approaching 4 is supposed to be equal to 1 over 4. Next example is f of x equals to x squared. L is 3. X naught is root 3. Epsilon is 0.1. So again, absolute value of f of x minus L has to be less than epsilon. So x squared minus 3 has to be less than 0.1, which means that x squared minus 3 is between 0.1 and negative 0.1, and we need to add 3 to all of them. So 3.1, and 3 minus 0.1 is going to be 2.9. Now x squared is between 3.1 and 2.9. What should we do here? What we need to do we need to make them the square root of 3.1, square root of 2.9. On the other hand, x minus x naught is supposed to be less than delta. So we have absolute value of x minus root 3 has to be less than delta. So x minus root 3 has to be less than delta and greater than negative delta. So x is delta plus root 3. And here you have negative delta plus root 3. So delta plus root 3 has to be equal to square root of 3 plus 1, and negative delta plus root 3 is square root of 2.9. So now delta is root 3.1 minus root 3, and this side you have root 3 minus root 2.9. So root 3 minus root 2.9 is approximately 0.029, and root 3.1 minus root 3 is approximately 0.028. So this one is smaller, so I'm gonna say 0.028. And then we can say that if x minus root 3 is less than 0.028, we can conclude that f of x is close enough to 3 because it's less than 0.1. So limit of f of x, which is x squared, when x is approaching root 3, supposed to be equal to 3. The next one is going to be f of x equal to x squared. L is 4, x naught is negative 2, epsilon is 0.5. So again, absolute value of f of x minus L less than epsilon. So f of x minus 4 is less than 0.5. It means that x squared minus 4 is between negative 0.5 and positive 0.5. So x squared is 4.5 and 3.5. So x is between square root of 4.5 and square root of 3.5. On the other hand, x minus x naught, the absolute value, is supposed to be less than delta, which is x minus negative 2, supposed to be less than delta. So x plus 2 is less than delta. So we can say x plus 2 less than delta and greater than negative delta. So x is delta minus 2, and here negative 2 negative delta, which makes it delta minus 2 equals to root 4.5, and here negative 2 minus delta equals to square root of 3.5. So delta is 2 plus root 4.5, and here delta is negative 2 minus square root of 3.5. So when you calculate that, that's gonna be okay. One thing I need to mention here, we have x squared between 3.5 and 4.5. You know, when you find out the square root, it can be positive or it can be negative. And so it means that the other possible way is going to be negative and negative root 4.5. The reason we need to accept this one, not this one, because x is around negative 2. So this one is not possible. However, this one is possible. So in this case, you have negative number, and here you have a positive number. So it's going to be these two. So if we calculate it, so 2 going to be negative 2 negative delta, supposed to be equal to negative root 4.5, and in here delta minus 2 supposed to be equal to negative root 3.5. So it's going to be negative or positive delta is going to be negative 2 plus root 4.5, and the other side is going to be 2 minus 3. So it's going to be negative 2 plus root 4.5. That's going to be 0.121, and here we have 2 minus square root of 3.5. That's going to be 0.129, and the smaller one is 0.121. So delta is going to be 0.121. You can say that x minus negative 2 supposed to be less than 0.121 is going to result in f of x is less than 4, which is going to be less than 0.5. So f of x minus 4, the absolute value, is supposed to be less than 0.5. So limit of f of x when x is approaching negative 2 supposed to be equal to 4. So these are gonna be the examples for finding deltas algebraically. I hope you enjoyed this video. If you like it, please like this video and share it to your friends, and don't forget to subscribe this channel. Thank you for watching and have a great day.